My name is Stephen Lothrop, and this is my projectile motion function. First we'll type in help projectile motion, find out what the function does. You can see we can plug in the initial velocity, the starting height, you can change the gravitational constant, you can have an initial vertical angle for the function and a final vertical angle for the function. You can also change the horizontal angle to plot in 3 dimensions, as well as change the time step to plot higher initial velocity. Now let's plug in some values and see what the function does. We'll start out with an initial velocity of 10, starting height of 5, gravitational constant of 9.81, change the initial angle to 15 degrees, take away the horizontal component, and plot the function. You see we have 4 trajectories plotted, starting with the initial trajectory and going to the final, and 2 in between. As outputs, we get the time to the maximum height, the location of the maximum height, and x and z components. You get the time till impact, the maximum height of the function of 45 degrees. You get the horizontal distance from x equals 0 to the point of impact, and total distance from our starting height until the point of impact. Now let's plug in some values to see what it does in 3 dimensions. To do that, we change the initial angle to equal the final angle, put in some horizontal component, and plot the function. You can see we're now in 3 dimensions. I put the grid on because I think it looks a little bit better that way. It's a little easier to see where you are. Get the same output as in 2 dimensions, but now we have an x, y, and z component for our output. Take a look at the code. This tells us what the function will do. We change the angles into radians, and then I have an if loop to decide whether the 2 angles are equal. So we can decide whether to plot in 3 dimensions or 2 dimensions. So if the angles are equal, we'll plot in 3 dimensions, and if the angles are not equal, then we'll plot in 2 dimensions and have multiple plots. And that's defined by this d degrees, which is a third of the difference between the initial trajectory and the final trajectory angle. At the end we have outputs, horizontal distance, total distance, maximum height, time of the maximum height, and the max height location. That is my projectile motion function.